Another area that brings questions is that of multicast networking. What is it? How is it used in Dante? And what do we need to worry about? In IP networking, unicast is a very common type of one-to-one traffic. Similar to a private conversation, data is sent uniquely from transmitter to receiver. No other devices see or process the traffic. If the transmitter needs to send the data to multiple receivers, it must duplicate that traffic for each one. Multicast is a type of one-to-many traffic. Left unmanaged, the behavior is similar to a public announcement. All receivers on the network receive the traffic, but the transmitter only has to send it once. Left unmanaged, all devices must devote some processing power to assessing these packets. Here is another way to imagine how unicast and multicast differ. In unicast, the transmitter must generate a data stream for each receiver, as if it is having a private conversation with each one. This becomes inefficient because as the number of receivers grow, all devices are getting the same data. Unmanaged multicast is more like a bullhorn sending the same data once to all receivers. In one-to-many settings, it is more efficient and less taxing on the transmitter or the sender of the data. If you know some networking, this description of unmanaged multicast sounds an awful lot like broadcast. There are, of course, differences. In unmanaged environments, both broadcast and multicast send data to all members of the LAN and are functionally equivalent. But multicast traffic can be managed in ways that broadcast cannot. Multicast traffic can be organized so that the only requesters of the data have to see it, eliminating the problem of unwanted traffic on some nodes. This organization is done at the switch using the feature called IGMP snooping. IGMP snooping determines which devices are actually requesting the data and makes sure that it only goes to that group of devices. When large amounts of multicast or broadcast are necessary, they are often segmented into different LANs to avoid problems with other devices. By default, Dante uses UNICAST to transmit audio between devices. When a subscription is set up, Dante devices create flows for efficient network use. Flows always contain 4 channels, even if not all are used for audio. This means that when sending unicast audio from one transmitter to one receiver, the bandwidth used remains the same, whether 1, 2, 3, or 4 channels of audio are in use. Adding a 5th channel subscription adds another flow. Because unicast flows are unique to each receiver, as we subscribe more receiving devices to a transmitter, the number of flows in use increases. Because flows contain 4 channels of audio, subscribing more channels of audio to a single receiver increases the number of flows in use. Dante transmitters support a limited number of flows, which may affect unicast and multicast decisions. Smaller Dante devices with 1 to 4 channels support 2 flows. Larger Dante devices with 16 or more channels support 32 flows. When a transmitter sends out audio to multiple receivers, each receiver needs separate flows even if each flow only contains 1 channel. This can be inefficient, causing the transmitter to resend this exact same data individually to each receiver. Eventually, the transmitter runs out of flows and cannot route more channels. This condition is called a fan-out. Dante controller will warn you when this condition is possible so that you can take steps to improve efficiency with multicast. With multicast, a transmitter can create a single flow that sends audio to as many receivers as desired, thus eliminating the problem of a fan-out condition. Multicast flows are created by users in Dante controller and contain up to 8 audio channels in a single flow. In Dante, multicast is invoked manually at the transmitter. No adjustments to receivers or subscriptions are necessary at all. If you receive a fan-out warning or simply wish to configure a set of channels for multicast in order to distribute them to multiple receivers, then it can be a good idea. For this, open the device view for the transmitter. Then, click the Create Multicast Flow button in the toolbar to open the Create Multicast dialog. Select up to 8 channels from the transmitter to include in the flow. You can create multiple flows if transmitting more than 8 channels. Then, click Create. That's it. You may delete a multicast flow too. It simply reverts to UNICAST and no subscriptions are changed. The question of control comes up frequently in discussion about multicast. What about all the traffic that is going to devices that aren't using it? Isn't that a problem? Actually, no. Not with gigabit networking, due to the large amount of surplus bandwidth. Even a large multicast of 64 channels represents less than 100 megabits per second of bandwidth, which is only 10% of a gigabit connection. Multicast traffic will slow down Wi-Fi networks. If you are connecting a Wi-Fi access point to a Dante network, be sure to engage the multicast filter function. By using multicast selectively, explicit management in a switch is largely unnecessary. In most environments, the actual need for one-to-many connections is often less than 16 channels. If you must control multicast, the tool to use is IGMP snooping, a feature found in managed switches. Let's review this unit. Dante uses UNICAST by default, sending data directly to receivers only. Dante packages audio channels into flows that typically contain several channels. Dante devices have a limited number of flows depending upon device type. A subscription to a receiver always uses at least one flow, regardless of number of channels. Unmanaged multicast sends the same data to all network devices regardless of subscriptions. When sending same audio channels to multiple receivers at once, consider creating multicast flows to increase efficiency and conserve available flows. Explicit management of multicast traffic using IGMP snooping is often not necessary on a gigabit network.